All right. Hi, all. We will continue the session from where we have left in the previous meetings. We started off with machine learning primer. We tried to understand about what is machine learning and things on those lines. And then, one second. Okay. So the first part or the part one of the training was machine learning primer. Then we moved on to part two, which include mathematical foundations. As part of this, we have covered optimization to some extent. Then you moved on to the part three, which is Python programming. Of course, you will not build websites using Python, but the Python programming, which is good enough for you all to get started with AI applications. Then we have part four now, which is again mathematical foundations. We'll continue with optimization, then do linear algebra, and then some amount of probability. Okay, so this is what we are going to learn. So the first thing that you need to understand from optimization perspective is that optimization includes something called as calculus, right? Derivatives. Derivative is nothing but finding the rate of change, the rate at which things change is derivative, and this is also called as gradient. Okay, so for example, if the value of x is going to change from 2 to 3, then what is the rate at which a specific function is changing, right? What is the rate at which a specific function is changing? How do you identify that? What is this function's value when x equal to 3? That is, just substitute 3 here, and then you get 12 minus 9, which will be 3. And substitute the value 2 here. So this is substituting x equal to 3. This is when you substitute x equal to 2. And when you solve it, you'll get a value that is called as rate of change or derivative or gradient. These all mean the same, right? Then what is a slope? Slope is if I change value of x, what is the rate at which the value of y is going to change, right? That's the rate of change, which is also given by slope. Slope is how steep the line is. And if you want to find slope at a single point or the rate of change at a single point, it is always 0. The rate of change at a single point is 0 or undefined rather. Not 0, it is undefined. Then we discussed about a few power rules, right, of derivative. D by dx of x raised to the power n is n into x raised to the power n minus 1. And the derivative can be represented as d by dx of x raised to the power 4 in this scenario, or it could be d by dx of, or it could be, sorry, f prime of x. Or you can also say y prime. The reason being y is equal to f of x. So you can either say f of x or the function is so much, or you can say y is equal to so much. When you want to find the derivative along with a constant, then you say constant into du by dx. For example, 7 is a constant. Constant means a value which doesn't change, right? Constant. 7 is 7, it doesn't change. But derivative of x raised to the power 4 will be treated as derivative of x raised to the power n, and this is what you get. Then you have the summation rule. You can either represent that as y prime, or you can say f prime, or you can say d by dx of the function y. However you want to denote. Okay, then you have a difference rule as well. This is how the difference rule will be. You just, segregate it, do the derivative of this separately and this separately. Do for this, and for this. Then any curve, remember again, this is important. Any curve can be represented as a function, right? And then you can start plotting it, for example. This is the origin, right? 0, 0. If x equal to 1, what will be the value of y? If x equal to 1, the value of y will be 3. So 1, 2, 3. So put a plot there. If the value is x equal to minus 1, then what will be the value of y? So x is equal to minus 1 will be here. The value of y will be once again the same. Then if x equal to 2, y value will be 9, right? Somewhere there. And same here. So when you try to connect those dots, this is how it will appear, like a curve. When x equal to 0, y will be equal to 1. Right? So this is how the curve will appear like. Right? So that's one thing that you need to remember. This is how it will appear, the curve. Okay, and then we went on with various examples. We tried to look at what is the derivative of sine theta. Derivative of sine is cos, derivative of cos is minus sine x. Then we looked at the product rule, then we looked at the quotient rule, right? Then derivative of tan is secant square x, chain rule and all that. Then for any given function, you want to find out on what are the critical points and whether those critical points are maxima or minima, right? I mean, we are about to get a project from a Sri Lankan client which is into logistics, right? So it's into transporting the goods from one point to another. The challenge is that on a specific day, how many trucks should be chosen for transportation? And if you're moving from point A to point B, then in between, what are the different other items this truck has to pick up or drop? Okay, and show me the route which is safest, fastest, and shortest. Shortest is the same, right? The yeah, fastest and shortest actually. Fastest need not always be the shortest. So this is the business problem, right? So optimize. Show me the most optimal route possible. Here, if the objective that you're trying to solve is find the fastest route possible, then you want to minimize. What do you want to minimize here? If you want to find the fastest route, then what will be your business objective? Can anyone throw some light? What do you want to minimize? And if you want to find the shortest route, then what is? Minimize the time, absolutely. Minimizing the distances. See, fastest route need not be the shortest route. When you say fastest route, then you want to reach to the destination very fast. So you want to minimize the time. Shortest route means you want to minimize the distance. Okay. So you need to either minimize something or maximize something, right? Um, okay. Let me give you an example of Google AdWords. Digital marketing is also making big rounds. Let's look at Google AdWords. For the amount of money that you spend on ads, what do you want to maximize? Sorry? No, not distance. Sorry. Oh, profits. Okay. Yeah. So here in Google AdWords, the objective is maximize the number of conversions. What do you mean by that? Say Amazon, when you search for a product, say you want to purchase iPhone, you say buy iPhone or iPhone 10s. In that way, you're going to issue a search command. Then organizations such as Amazon would pay Google some amount and you will see an ad. If you see an ad, what do? You will click on that, right? That's called as click through rate. So how many times you are showing that ad and how many people are clicking on that is something that you have to look at. Impression means how many times are you showing that ad and how many times people have actually clicked on it. And in this scenario, it is called as maximizing the click through rate. After you click, you have to go to the website and you have to purchase that product. That's called as conversion. Conversion means from the time a person clicks on the ad till the time that person purchases. That's called as conversion. So you might want to maximize the number of conversions. So the point that I'm trying to drive is, given a business problem, you might want to minimize something or you might want to maximize something. Okay. And sometimes there might be constraints which might be levied on you. But with respect to neural network, we will discuss about unconstrained optimization problems. Means there are no constraints levied on you, right? So that's how your deep learning algorithms work.